Okay, let's look at our 2022 paper 2 question 7. All right, this is a three-dimensional trigonometry. Every time we have a three-dimensional trigonometry, the things that should come to your mind is you want to find a right angle triangle. Okay, so we aim to always look for right angle triangles from here. So there's a cuboid, they are labeled A, B, C, D, E, F, G, H. So every single vertices is labeled. There's an X somewhere. So there's an X here, right? Okay, so AB is 24. BC is 13 and AE is 8. Oh, very nice. They label for me everything, okay? So now we have this line over here which says that X is a point on EF such that XF is 3 is to 5. Okay, what I'm going to do is I'm just going to put down like that 1, 2, 3. 1, 2, 3, 4, 5. But the good thing is, right, because you already know that the entire thing is 24, right? Actually, you can straight away take 24 divided by 8 because there's 8 units kind of, right? So then after that, this one of it is 9. You can just put 9 cm here, whereas the other one is 15 cm. Is it in cm? Yeah, correct. Okay, so you want to find the area of the trapezium ABXE. Let's see. So ABXE, where is it? ABX and then E. Oh, that's okay. Because it's like it's just that part that's facing me, right? So it's already a right angle. Can you see that? Okay, so it's already a right angle from here. What's the formula for area of trapezium though? Half sum of parallel sides. So your parallel sides is 9 plus 24, right? Your height is the vertical height. So just need to times 8. So just press your calculator. Half then 9 plus 24, oops, 24, then times 8. So it's just 132 cm square. Nice number. Very easy. Okay, so then after that, from here, do I remove it? Why did they ask me to find this random trapezium though? Okay, so they want me to calculate xg. So xg, where is xg? I knew it was going to be like funny position. Okay, so xg is from here all the way to here. But what you understand is think of it as flat ground. Yes, it does not look like it, but it's on the rectangle, right? So since it's on the rectangle, right, this one over here is a right angle. So actually this one here should be a very, I think it's a 1 mark question only. So this one you got to just use your Pythagoras theorem. Okay, so you have your, this part here will be 13, right? So this one is 13 because same as BC, right? So xg is the hypotenuse. So we have xg square will be 15 square plus 13 square. So to find your xg, you just need to square root and then you'll be able to get this. I just put a bit more SF just in case. I don't know whether I need it below or not. So 19.8 for 3 significant figures. So quite easy, this one. Still okay, right? Okay, we look at the next part. The next part here has a new cuboid looking thing, but actually it's the same thing, just that they remove some part, right? So they remove a pyramid, and you can see that the base of that pyramid, right, was a triangle. That's why you got that shaded thing over here, lah. Alright, yeah, so they say triangle BGX. Okay, so what we're going to do is we have the values, right? So we label, okay? What do I have? I think I only have XG. Okay, let me put down the 5SF1. See, I knew it was going to need it somewhere. That's why we try to play safe and write the 5SF. You know, I need to work with 3SF. Then not accurate already lah, ho. So 19.849. Okay, so they want this entire triangle here. So this is, I don't know how many marks this is. I think a bit more. I think 3 if I'm not wrong, 3 or 4. Okay, so what I have here is that you want to find the area of the triangle. The first thing that should come to your mind, right, is that, hey, this is not a right angle triangle leh. So since it's not a right angle triangle, the rules that comes to my mind should be my sine rule and my cosine rule. Okay? So only when you're in a right angle triangle, right, then you think of Pythagoras theorem lah, you think of what's that called? Tokaso, right? So this one should be a sine rule and cosine rule thing. Okay, we're going to take it slow. We're going to see what we have. Okay, but what I can find very quickly is I can find this line over here. Why can I find this line? Because this is on the cuboid, remember? The cuboid had rectangular faces, right? Which means even though it doesn't look like it, this is actually a right angle. Can you see that? And then GC is the height, right? So that one here gives me 8 here. So I'm going to use my Pythagoras theorem. Okay, so I use my Pythagoras theorem to find BG, all right, which is like that. BG square equals to 8 square plus 13 square. So when I do BG, I'm just going to shortcut press calculator. You all write out the steps, okay? This is 15.264. Okay, so this one here, I'm going to just label 15, oopsie daisy, wait, 15.264, like that. Okay, then after that, now what I have here is that we need to find another length. Okay, so the other length from here, right? Same thing, okay? I can cut into a right angle triangle. So if you recall, right, just now we found it because we knew this part here. This part was 9, is it? Yes, this part was 9 cm, which allows me to understand that this part here is 15 cm. So 15 over here and 8 over here, Pythagoras again, right? So I can Pythagoras to find my xb. Okay, I use a lighter blue, okay? Okay, so I'll find my xb square, which is 15 square plus 8 square. So my xb, same thing, I'm going to just use my calculator, 15 square plus 8 square. Oh, nice number, 17. Okay, so I managed to get this particular value, which is 17. So there's no like height or anything to this triangle, right? So what I need to do, I think I have quite a few marks for this one, but I cannot recall. Okay, so what I would think of is, okay, area of triangle now, I'm going to make use of half AB sine C. But where's my C? I got no angle, right? I got to find one angle. So I'm going to determine whichever angle. Maybe I'll just try, there's no right or wrong. Okay, I will try XGB. All right, so we're going to use what rule? We got three lengths and one angle. That means we're going to use our cosine rule. All right, your cosine rule looks like this. A square equals to B square plus C square minus 2BC cosine A. So important thing you need to note for me is this one is the length, this is the corresponding angle. So what I have is I'm going to plug in, maybe I call this theta lah, okay? Okay, so the first length that comes in is 17 square. The other two anyhow, jump, never mind, okay? 19.849 square plus 15.264 square minus, oh no, no space, wait minus 2BC. No space. Okay, I'll bring it down, okay? Okay, so here, then after that, cosine theta. So normally, right, what happens here is that if you're using cosine rule, the very typical one is you're going to find this length actually, usually lah. Then you just square root, then you get this length already, right? But now, what we have is we need to find the angle. So I don't want you all to memorize a new formula. So I'm going to just do different colors like that, okay? So we're going to do separately. So this one here, the yellow one is 289. The blue one is 19.849 square plus 15.264 square. So this one 626.97. Good enough. All right. Then after that, the pink one is minus 2 times 19.849 times 15.264. So this one here will be 605.95 cosine theta. Okay, so what I'm going to do is I'm going to move the cosine theta to the left side. So the 605 thing, right, becomes a positive, correct? Like that. Then you can take the blue minus the yellow, all right? 626.97 minus 289. Minus 289. Okay, so this one here will be 337.97. What I'm going to do is I'm going to bring, I'm going to bring this guy over. So it becomes a divide. So bringing this over already, right? If I want theta only, bring over the cosine. So cosine inverse this entire thing. So just press calculator. Make sure you're in the degree mode, okay? 337.97 over 605.95. So then your angle will be over here. Just give more angles, more decimal place. 0995. All right. Okay, so now we have this angle. I can put this inside here, which is 56.0995. Okay. Okay, so now you can do half AB sine C already. So half AB sine C. All right, very tedious. Okay, now that you got all the lengths and everything, you even managed to find the angle, right? Okay, so what we have here is that you can use your area of triangles, the formula, half AB sine C. So 19.849, 15.264 sine C is like that. Okay, so this is the area of the triangle, the last part. So you just punch into your calculator. Remember when you use the formula, right? A and B must kiap to form C like that, okay? So half, what is this? 19.849, 15.264 sine 56.099. Okay, so you got your final answer here. They never say anything about final answer, so you just leave. It's already final already. So just write as 3SF 126 cm square. So this is the final answer for part C. All right. So from this question, what I want you to review is when you see trigonometry, three-dimensional. I want you to use think of right angle triangles. Okay, your Tuakaso or your Pythagoras theorem. When you see non-right angle triangle, the things that come to your mind, sine rule and then cosine rule. So when you want area of triangle, you think of half times base times height or half AB sine C, right? So to have half AB sine C, you need two lengths. You need one angle. So how are you going to get your two lengths and one angle? So this question is very, very good because they test you everything that you need to know about your trigonometry already.